Okay, ma. Good evening. Okay, today I'm going to take one chapter in organic chemistry. One of the chapters in organic chemistry that's called biomolecules. Okay, so very simple one. This biomolecules and polymers only I'm going to take today itself. Okay, right. Simple one. Why it is called biomolecules means the molecules are useful to do some biological activity. Isn't it correct or not? So you know that without these molecules, there is no biological activity in our body, isn't it? That's why it's called biomolecules. This function and all we are going to study how it is made up of, what are the elements, how the groups are linked. Okay, this and all we are going to study in this chapter. First one here we have four topics is there. One is called we are going to study about carbohydrate. Next one is proteins. Next one is vitamins, hormones, enzyme. Okay, this is all small topic. Last one, nucleic acid is there. Okay, so the major topic is we have only carbohydrate and proteins. Understood? The other thing is a very small thing. It's small chapters, small topics you can able to study yourself. Okay, so I'm going to take only the carbohydrate and proteins. Okay, so carbohydrate. First of all, we are going to study about carbohydrate. What is carbohydrate? It is made up of what are the elements? Carbon, hydrogen, oxygen. It's called carbohydrate. No? Okay. It is a polyhydroxy. Aldehyde or ketones. We can say generally we can say it's a polymers. Understood? So it is here they classify the carbohydrate into two types. What we can say sugar and first we are going to study about the carbohydrate classification. Okay, sugar and non-sugar. What is the meaning for this? Sugar is tasty. It's called tasteless. No. Okay. So sugar nothing but sugar. Again they classify into non-sugar nothing but it's called polysaccharides. Saccharides means nothing but sugar units. It's called saccharides. Understood? Sugar they classify into two types. One is called monosaccharides. Monosaccharides. This is all studied. Monosaccharides and oligosaccharides. Okay. So monosaccharides means mono means one. No. Okay. It is only one unit. It cannot be hydrolyzed it cannot be hydrolyzed. Okay. So cannot be hydrolyzed is called that is called we can say monosaccharides. Can be hydrolyzed. It can be hydrolyzed. It's called oligosaccharides. It can be hydrolyzed to give what? To give 2 to 10 monosaccharides. Are you following? It can be understood. That's the main difference between this and this. Cannot be hydrolyzed, can be hydrolyzed. To give 2 to 10 monosaccharides. If it gives exactly 2 means what? Okay, oligosaccharides. Under this we have now first we are going to see one examples. Monosaccharides means it cannot be hydrolyzed. No, so we can say it's called what? Glucose, fructose, not sucrose, galactose. Understood? These are all example. Okay. Oligo means under this we have so many categories are there. If it I am saying it can be hydrolyzed to give 2 to 10 monosaccharide. If it give exactly 2 means it's called disaccharide. If it give exactly 3 means trisaccharides, tetrasaccharides, up to 10 it goes on. Okay. So under this we are going to study about only the disaccharides. What is disaccharides? Disaccharides means it can be hydrolyzed to produce what? Only 2 monosaccharide. That's what's called disaccharides. Understood? Disaccharides. Are you following? Disaccharides nothing but example is I am saying C12H22O11 plus H2O. Are you following? Okay. I am saying this is a disaccharides because it is going to produce 2 monosaccharides. That's why it's called what? Disaccharides. Example nothing but sucrose. Sucrose is a disaccharide because when we add water it produces 2 monosaccharide. Understood? CH12O6. Sorry. Okay. This is called glucose. Is called what? Fructose. Understood? Are you following? Likewise, trisaccharides, examples, raffinose, so many examples are there, okay. Disaccharide, trisaccharides, tetrasaccharides, it goes on, okay. Then, come to, are you following? Disaccharides, so many disaccharides are there. We have lactose, we have maltose, okay. Okay. Then, non-sugar, what? It's called polysaccharides. I'm saying, when we add water, what happens? It produces, when we add water, it produces what? Examples, cellulose. Cellulose is a polysaccharide. Cellulose or starch or, okay, glycogen. This is all we can say. When we add water, what happens? It produces n number of monosaccharide. Correct or not? Understood? If it produces n number of monosaccharides, then only it's called what? Polysaccharides. Understood? So these are the major classification about this. Okay. Each and everyone study examples. Monosaccharides, what are the examples? Disaccharides, what are the examples? Polysaccharides, what are the examples? Okay. Understood? Are you following? It's a major classification. Next one is, now we are going to study about only the glucose structure, how they frame the glucose structure, how then fructose is also given, some structures given in a textbook, okay. Then we are going to study about disaccharide. Disaccharides only we have how the linkage will be there in case of sucrose, lactose, maltose, okay. Then polysaccharide also we are going to study about how the linkage, how it is made up of. This is not only we are going to study. Here I given only the examples. Okay, are you following? Right. Next one is here we are going to study about the structure of glucose. Okay, that's one important topic under this. Okay, now listen here, how, see, structure of glucose, how they got the structure of glucose. They are doing some test with glucose. Then only we can think it consists of OH group, it consists of aldehyde group, okay. Then how many OH group, okay. So this and all they are all finding by using some test. After that they are giving the test, they are giving the structure to the glucose, okay. So compulsory, I expect one questions from here. Structure of glucose, understood? Right. Okay, right. So the molecular formula. What is the molecular formula? C6. Molecular formula is what? C6 H12O6. That molecular formula. By molecular weight determination, elemental analysis method, they are finding how many carbon, how many hydrogen, how many oxygen they are finding. Elemental analysis method is there. Okay. So by using that method, we can find out if you take any compounds, how many elements are there, what are the elements are there, we can find out. By using this, they are giving the molecular formula for glucose. Okay, that's the first point. Second one, we don't know the structure, no. Then I put G. G stands for glucose. Okay, take glucose. They are doing, it undergoes reduction. It undergoes reduction by hydrogen iodide. It forms. We don't know what it consists of. We are doing one test. If it undergoes reduction, it produces NX in one compound. From the product only we can decide what it's made up of. Okay, NXN means how many carbon? 6 carbon. That 6 carbon in what? Straight chain, no? From this we can decide, we can guess it contains 6 carbon. 6 carbon in what? Straight chain. Are you following? Understood? From the product only we can guess it consists of 6 carbon. That 6 carbon in what? straight chain. This is the first point. Understood? Second one, how they test the carbonyl group. It's called, carbonyl group. Carbonyl group. Carbonyl group. Suppose if any compounds having carbonyl group, it should react with what? HCN as well as NH2OH. Okay. Suppose here, before that I put what? Only G. G stands for glucose. No. Any compounds having carbonyl group, it should be compulsory react with the hydrogen cyanide as well as NH2OH. See, now instead of G, I put one structure for the glucose. Here, what's the structure means? C double bond OH. Just remember CHOH 4 times CH2OH. This is the formula for glucose. Okay. Any not only this one, any ketone, aldehyde, any compounds having carbonyl group, no, that compulsory reacts with HCN as well as. Okay. So this test proves that it contains carbonyl group. Are you following? Okay. So what happened? Plus minus. Last class we studied, plus minus. Are you following? So this goes here, no. This goes here, no. Understood? So it forms what? Cyanohydrine on compound. That. So what's the product? COH, CN, H, CHOH, cut or not? 4 times CH2OH. Understood? Plus. Likewise, you remember, this is called hydroxylamine. You just imagine, what is this? Another compound. NOH is obtained. So this forms cyanohydrine. Cyanohydrine. This forms, NOH will be formed. Okay? See, H, double bond, NOH. Are you following? CHOH, CHOH 4 times CH2OH. Are you following? See, glucose reacts with hydrogen cyanide to form cyanohydrine. Glucose reacts with hydroxylamine to form oxime. Okay. So these two reactions, from these two reactions we can guess it contains what? What group? Carbonyl group. That's all. Okay. Slowly they are doing some tests. From this and after that we guess it consists of this and all. Okay. Right. Next one. Fourth one. I'll write it here. It's a very important oxidation test. They're doing oxidation. Suppose what's the formula for glucose? CHOH. CHOH how many times? 4 times CH2. Just memorize this one. Okay. Glucose oxidized by bromine water. Okay. It produces one acids. Okay. What acids means? Suppose the CHO becomes what? Tell me. CHO becomes what? COOH. Are you following? Okay. This is called, we can say, gluconic acid. Gluconic acid. If you get any acid means, it should have only aldehyde group is there. If there is no aldehyde group, we are not getting any acid, no. If you have aldehyde group present in glucose, then only we can get what? Gluconic acid. Okay. Are you following? So in this reaction proves that what? Presence of what? Aldehyde group, cut or not? In glucose. Are you following? If the aldehyde group is there, then only it is giving one acid. So, okay, right. Another one, I am writing like this, in this way. See, it is oxidized by, strong oxidizing agent. Okay, so what? It produces, see, here, strong oxidizing agent means this also becomes COH, this also becomes COH group. Understood? Okay, now listen, COH, CHOH, understood? 4 times COH. This is called, we can say what? Saccharic acid. Are you following? So this proves that for getting this is very important. For getting gluconic acid, what group it has? Aldehyde group. For getting saccharic acid, what group it has? It has what? This product proves that presence of what? Primary alcohol group. Are you following? This becomes what? Primary alcohol group becomes what? COH group. So this reaction proves that it consists of what? Primary alkyl group. Okay, understood? So these are the important points. Okay, again, okay, anyhow, it contains aldehyde group. Then only they are doing what? Tolerance test. Tolerance is the test for what? Tolerance test is the test for what? Aldehyde, you know. Understood? Right. I written all this one, first point. First point, second point. Okay. Okay, right. Okay. So fifth point, I'll write it here. So anyhow, it contains aldehyde group, no? Okay. So we are doing what? It answers what? What? It reduces glucose. It means what? Glucose. Glucose reduces what? Tolerance reagent. Okay. Then only we can confirm it consists of aldehyde group. Understood? Glucose reduces tolerance reagent. From this, we can confirm the glucose having what? Aldehyde group. Okay. Then one more test they are doing. You know, CHOH, so CHOH 4 times, CH2OH. Understood? Okay. It reacts with acetic anhydride. Acetic anhydride. Anhydride. See, just you remember like this, you know. How many OH group here? 4 secondary alkyl group, 1 primary alkyl group. Understood? Just replace, if you add acetic anhydride, what's the use of this means? You replace H by what? Acetyl group will come. Acetyl group will come. Just remember like this. Replace H by what? Replace H by what? Acetyl group. You put acetyl group. So what happened? You just remember like this. CHO, instead of H, you put acetyl group. C double bond O, CH3. How many times? 4 times. Here also. CH2O, C double bond O, CH3. There are how many acetyl group? 4 plus 1, 5. So it produces what? Pentacetate. Pentacetate. Okay. Any compounds produces pentacetate. Okay. Pentacetate. No. Pentacetate. This proves that it contains what? How many OH group? How many OH group? 5 OH group. From the product only we can guess it consists of this one. Okay. For getting gluconic acid, it consists of aldehyde group. For getting saccharic acid, it consists of primary alkyl group. For getting pentacetate, it consists of 5 OH group. Okay. For getting cyanohydrine and ioxime, it consists of what? Carbonyl group. Okay. So this and all from the information only they are giving the structure to what? Structure to glucose. Understood? Right. Right, fast. Finish this one. Okay. Right. So all this information, at last we are giving the structure to glucose. Okay. What is the structure means? Structure of glucose. You know that? How many carbon it has? 6 carbon. The 6 carbon straight chain, no? That's the first point we studied, no? It produces NX chain. 6 carbon straight chain. Then it consists of aldehyde group, I told you, no? It consists of aldehyde group. Aldehyde group means always is a terminal functional group. Terminal, it will be end first or last, no? Right. So always, correct or not? CHO. It consists of how many OH group? 5 OH group. So you put 5 OH group. From top, the second position you put OH group right hand side, third only you put left hand side. Just remember like that. Then after that, no problem. You can write as it is. Understood? When you go top to bottom, CHO first, second one OH in right hand side, third only put left hand side OH. Okay, right. Then you can fill by hydrogen, no? H. If you have OH means H. If you have OH means put H. If you have OH, put H. If you have OH, last only what? CH2OH, correct or not? Last only CH2, primary, no? Primary. So we have this 5 OH group. Among 5 OH group, one only is primary, other 4 are secondary. This is what? Aldehyde group. Understood? Right. Anyone question they will ask from this? Okay. Okay. Structure of glucose. Study the name, IPS name is also given in textbook. Okay. It's called XNL. 6 means XNL. Okay. 1, 2, 3, 4, 5 pentahydroxy XNL. Not 1, 2. You start from here, no? You start from here. So 2, so 2, 3, 4, 5, 6 pentahydroxy XNL. Okay, it's given in a textbook. So this one, you just copy them. It's enough. Understood? Then they are giving one cyclic structure. Cyclic structure to glucose. Okay, cyclic structure means here finished to this. Finished, all right, okay. So this is all no? How many sometimes they'll ask how many primary alcohol, secondary alcohol, this is all just study. Then how many chiral carbon also study. How many carbon? 1, 2, 3, 4. This is not a chiral carbon. HH, no, similar, all the, what is chiral carbon? All the groups are different. Okay, so it has what? 4 chiral carbon, just you write, okay, right. 4 chiral carbon, right. So these are the information about glucose. Now we are going to study about cyclic structure. Cyclic structure means here, simply they are going to rearrange. See here, cyclic means, open chain, this is called open chain structure. Open chain structure only the CH will be free. It can answer what? Tolerance test, okay. So, but in cyclic structure, what happens means here, the fifth carbon, 1, 2, 3, 4, this fifth carbon, just remember, this H goes and combines with the OH, it becomes O. This H goes here, it becomes OH, okay. Now, it becomes OH means what? It becomes OH. Now, it forms a cyclic structure. Okay, like this. Okay. Now there is no CH group is there. It will not answer tolerance test. It will not undergo 2,4 DNP test. Okay, sodium bisulfate test. Mostly aldehyde test will not answer because there is no CHO group, isn't it? Okay. The same thing. We are going, this is a cyclic structure. Okay. This only here. Now we are going to differentiate this part only. This is called, we are saying what? Alpha D plus glucose. Another one is we are going to write beta D plus glucose. Okay. So here difference in configuration we can say. So here we can write in other way, outright. OH I put left hand side, H in right hand side. That's only difference. Otherwise everything same. So this is called, we can say what? Are you following? I put OH here. Understood? Remaining as it is, no changes. Okay? Right. Okay, right. Here difference only in what? The difference only in particular carbon. That's why it's called what? What carbon? What is this actually? Anomers, no? What is anomers? Difference in two structure only in configuration. This is D configuration, this is called L configuration. So difference, here OH right hand side, this is called OH in, it's OH right hand side, this is OH in left hand side. That's why it's called anomers, we can say. Okay. Difference in configuration at particular carbon is called what? We can say anomers. Okay, right. So example, alpha D glucose and beta D glucose is the example of anomers. Okay. Simply you can say what is anomer means, also just write. I'll write simply difference in configuration at particular carbon. At, in this case, at what? C1, no? Cut or not? C1, cut or not? Difference only in C1. Difference in configuration at C1. In this case, this. Are you following? Right. Okay. Right. That's all. Then This is called cyclic structure. Okay. Then one more structure they are giving, that is Haworth structure. Haworth. We simply compare this one with Haworth structure. Haworth, one scientist, he has given one structure to this glucose. This is also cyclic form. It's a closed cyclic. Okay. So he took one compound. That compound is called pyran. Pyran means it's a 6-membered ring. Just remember, it's a 6-membered ring like this. It's a heterocyclic compounds. Now we are going to put glucose in this form. In this form, it's a heterocyclic compounds. No. Okay. See, just remember like this. Here I will put one structure, that is Okay, right. So here I put oxygen in the. Okay, here. Okay. Simply remember. Okay, structure and all they want to ask. Mostly Haworth structure, he took what compound? Pyran. It's a heterocyclic compounds. It is a 6-membered ring. This is all you study. Okay. What is anomer? Structure means here. See, C1 only difference. This is all important. C1. See, all the left hand side, no? All the left hand side structure, left hand side group you put on top. Just remember like this. Right hand side, no, some groups are right hand side, no? You put on bottom. Remember like this. Okay. Top, say right. Top is what? H. Correct or not? H. OH. H. Here, if I put H means this CH group is no. So it is. We cannot be able to put this CH big group. No, we cannot put inside. So then only some changes. So what? H what? Very big group. No. Then only some small changes. Then H means OH. H means OH. OH means H. H means what? Okay, that's all. Understood? This is alpha D plus glucopyranose. Same way we can write what? Alpha D glucose or beta D plus glucopyranose. Alpha and beta, that only differences. Okay. Both the cases we have plus only because glucose is a dextrorotatory. Okay. Finished. This only difference. Haworth structure. This one another structure. Beta D glucopyranose. You put OH on down, up, H on down. This only difference. Otherwise everything same. Okay. Right. Finished. Our structure, cyclic structure, open chain structure. Okay. Open chain structure only can answerable to everyone. Okay, all the tests. But cyclic structure will not answer. Finished, right? It's given in your textbook clearly. How it comes only just remember. Okay. If you understand, if you listening means you can ease to study. Otherwise, it will take some time to study. Okay, right. Next one. So fructose is given. Fructose is what? What's the main difference between this and this means? Glucose and fructose is a keto. That the glucose is aldohexoses. This is called ketohexoses. Simply you can say. That is called it will not ox is by bromine water. The point and all they didn't give directly. They are given the structure to this. Okay. That is the dextrorotatory, this is called lava rotatory. That is in grape sugar, this is in fruit sugar. That's called aldohexoses, this is called ketohexoses. So like this, you differentiate and prepare. But what's the structure means? It's kind of keto group, I told you, no? Keto group. So here simply we can write like this. CHOH 3 times CH2OH. Understood? Right. Here also we have, if you want means, you can extend and write OH, OH, this only, I told you, no? Third only what? This side. Correct or not? Check. H, here also H, CH2OH as usual. Okay. That is called pyrono structure, no? This is called furono structure, furon. This is called open state structure. What happened? This H goes here, it becomes OH. Now, how to write this one? See, when H goes here, it becomes OH. The CH2 we should write like this. It will come this side. Okay. So CH2 OH. Understood? Here single bond. Correct or not? Now in station we have only carbon 5 only is there. Correct or not? When it goes here, we should write in this direction. Okay. So OH. Then H, OH, O. You know, it makes a cyclic, no? It makes cyclic, no? Correct or not? Then whenever here, wherever the H is there, we put OH. OH is there, put H. Here, H. Then as usual, CH2OH. Correct or not? Check. Take the structure. Then this is what? Alpha D. Alpha D. Here differential configuration, no? Differential configuration at particular carbon, no? Understood? So particular carbon only differentiate. What is this? Here, here, this side outright. C, right hand side OH, no? Left hand side, put OH. The right hand side, CH2OH. Okay. Then remaining group as it is, no changes. Correct or not? Okay. Difference only in particular carbon. Okay. Here changes in carbon but 2. That's remember. That is 1. Last class we studied 1, no? This is 2. Correct or not? Difference in, that also anomeric carbon. This is also anomeric carbon. But difference in glucose, anomeric carbon in 1. Here anomeric carbon 2. Understood? Right. What's the name is given? See me. Tell me. Alpha? D. That's only difference. Alpha D minus fructose da. This is called only fructose. Furanose, after that it will come. Alpha D minus, so beta, no? Beta D, sorry. Beta D fructose. It is fructose only. Then this two is, then only it's called what? This two is called what? We can say anomers. Understood? Okay, right. Are you following? Okay. See the difference. That is C1, here C2. Okay, right. Then next one. Here also Haworth has given one structure. What it's giving means Haworth structure is called nothing but what? Here he took one compound. He took only 5-membered ring. Okay. So 5-membered ring. What he took means he took one compound what? Furon, no? Okay, you took furan. Okay, it's a 5-member ring, it's heterocyclic compounds. You know that furan means what? It will be like this. Understood? It will be like this. Furan. So here only one structure I will give. You know, oxygen. Understood? Right. Here 1, 2, 3, 4. Okay, see this. I told you, no, left hand side group we put on top. Left hand side group O is CH2OH. Then here difference only, this is carbon number 2. This is CH2OH, cut or not? Here OH, cut or? Then top OH, here H. Top H, OH. Understood? Right. Next one. Now, top as usual, you know, but it is an outside only. Okay. Then as usual here also, last only they actually H on top. No, see the book. What? H on down. Down. The last, the glucose also we are doing like this. It's the same principle, but even though it is outside, we put outer the, you know, ring, but here the same rule they are following. So what? CH2OH, then H. Okay. If you go, this is called what? Alpha D minus fructofuranose. Okay. Alpha D minus fructofuranose. Understood? Then same thing you change. Differ only in which carbon is differ? This is 1, no? 2, kata, 3, 4, 5, 6, kata not? Okay. Differ only in carbon number 2. Next. Understood? Okay. So monosaccharides over, completed, isn't it? So study the structure of glucose is very, very important. That point is very, very important. Okay. Next one is disaccharides. Written all this, right? This is not important. Furan, that is pyran. Okay. These are dextrorotatory, this is lava rotatory. Okay. Anomeric carbon C1, here C2. Okay. Just compare grape sugar, fruit sugar, aldose, keto. Okay. Glucose reduces tolerance agent, fructose does not reduce tolerance agent. Glucose oxidizes bromine water, no, yes, bromine oxidized by bromine water to get what? Gluconic acid. But fructose cannot be oxidized by bromine water. Okay. Then only cannot be oxidized means it does not having any aldehyde group. We can prove that. Understood? Understood? Right. Next one is okay. You know, disaccharides. Disaccharides means I told you, simple one. You just study the what examples only. What is disaccharides? It gives what? 2 monosaccharides and hydrolysis. Simply you can say. Okay. You know, disaccharides. You know, first I am saying sucrose. Sucrose. How it is made up of? Sucrose means it consists of what? 2 monosaccharides. No, that's why it's called disaccharide. Understood? You know, maltose. This also consists of 2 monosaccharide. You know, lactose. This also consists of 2 monosaccharides. Okay. How the 2 monosaccharides are linked means it consists of what? One linkage. It's called glycosidic linkage. Have you heard about this one? It's called nothing but oxide bridge. Okay. Or we can say it's called ether bridge. Correct or not? Ether means what? What's the formula for ether? O in the middle, no? That O only is the middle. Okay. Here on monosaccharide, here on monosaccharides. Understood? So it consists of two monosaccharides. The two monosaccharides are linked by what bridge? Oxide bridge. Understood? Right. Then the linkage also just keep in mind. Okay, it consists of the linkage between C alpha D glucose of, you write like this, C1 of alpha D glucose and C2 of beta D fructose. Just right. The linkage only they'll ask C1, C2. Okay. It consists of two monosaccharide. In two monosaccharide, one side glucose, one side fructose. In between oxygen is there. In glucose C1, in fructose C2. In between what bridge is there? Oxide. You see the structure, you can able to understand. Okay. Then maltose. Here one C1, C4. C1. This is maltose means fully made up of glucose. So alpha D glucose and same thing, same C4. This only difference. C1 of alpha D glucose and C4 of alpha D glucose. Both are same. Just right. Lactose also, C1 of beta D. Galactose. This is called galactose. Somewhat different one. Galactose and C4 of beta D glucose. Okay, correct or not? Okay. So the linkage only will be very important. Okay, just go through. Then this only I am saying what? This only is called non-reducing sugar. Non-reducing means what? What is non-reducing sugar? It's not. This one is called non-reducing sugar. Non-reducing sugar. Okay. Because CHO is not free. But this is all what? Reducing sugar. This is also what? Reducing sugar. Understood? Right. This is all just note down. It's enough. Other thing, just go through your textbook. Mostly I covered everything. Understood? Disaccharides. Okay. Next one, I finished? Right. Next one, polysaccharides. Polysaccharides. Polysaccharides means, what is polysaccharides? What is polysaccharides? It produces n number of monosaccharides on hydrolysis. N number. Okay. So example what? You can say first textbook starch is there. Okay. In a textbook starch, cellulose and glycogen. These are the examples is given in a textbook. Starch, starch, all the polysaccharides, what's the formula? C6H10O5 in n times. That or not? C6H10O5 in n times. It's the formula. It consists of, starch is a polymer of, just remember this one is a polymer of alpha, correct or not? So keep polymer of alpha glucose, alpha D. Yeah, it's alpha D. Alpha D. Cellulose is a polymer of beta D glucose. Polymers. It consists of more units of glucose. Okay. So it consists of two units. That. What is that? Amylose and amylose and amylopectin. Okay. Then the properties and all you study yourself. It's a water soluble, what is insoluble. Okay. Water soluble. If you want me, just write important points. I'll give. What is insoluble? 15 to 20% starch is there, that or not? Nearly 85% starch is there. Okay, the linkage only just study. linkage is very important. C1, just say simple. C1 C4 alpha D glucose units. C1 C4. Correct or not? Check once again. Mostly the third only is the correct one. 1 second, I'll tell correctly, exactly. That is 1 second. C1, the linkage is C1 C4 glycoside linkage, C1 C4. Okay. But sometimes C1 correct only. C1, this only C1 or we can say C1 and C6. Okay. Alpha D glucose or we can say glycoside linkage, both are same. It is everything made up of glucose, but the C1 C4 only linked in between the glycosidic linkage between C1 C4. Here sometimes C1 C4 or sometimes C1 C6. Okay, right. Okay, then that here cellulose. Cellulose, it's a polymer of, simply just remember, polymer of beta D glucose. That's the first point, remember. Okay, polymer of beta D glucose. Okay. Right. Next one. Here also, it is present in cell wall. Okay. Plants, cell wall. It is present. That. Then this also, the linkage will be C1 and C4 glycosidic linkage. Glycosidic linkage. Okay, right. Let's only copy them. Then third one is that what is it? Third one is glycogen. Glycogen otherwise it's called animal starch, no? Animal starch, because it looks like the structure of amylopectin. Then only they are saying it looks like. This is also important. Why it is called animal starch? It is a structure. It structure similar to amylopectin. It is always present in liver, muscle, and all the brain also they put. Okay, it decomposes into glucose. The body needs by enzyme. Okay, it is stored in liver. If you want glucose means any enzyme can be decomposed this one to produces glucose. Okay, that this is all information. Just go through. Okay, this is all information about what? Carbohydrate. Okay, so we studied monosaccharides, disaccharides, and polysaccharides. Understood? Right. Next one, we are going to study about protein. Okay, right. Protein. Carbohydrate only carbon, hydrogen, oxygen. Yeah. Here one more element. What is the one more element? What is this? Nitrogen. Carbon, hydrogen, oxygen, and nitrogen. Okay. Okay. Simply we can say when we add water, it produces what? Hydrolysis of protein to get alpha amino acids. Understood? It produces amino acids. Okay. What is amino acid means? It consists of what? Amino group. Amino group means NH2, COOH, this side H, this side what? CH3, or any alkyl group. Any alkyl means R I put. Understood? Okay, amino acids, understood? Amine is a basic character. Are you following? Amine is a, basic character. Acids mean, carboxylic acid, it's called acidic character. Then only we can say, it's called what? We can say, it has both, no? Then only we can say what? What character? Amphoteric. Understood? Amphoteric nature. Or sometimes we can say both the characters are neutral, no? It's called neutral. Character will be neutral. Okay, right. Okay. Then we have, types of amino acids. Then essential amino acids, non-essential amino acids. It is obtained from, essential means what? You study, what is essential? Types means what? Essential amino acids. Essential amino acids. Non-essential amino acids. This obtained from, from our, we are taking food, no? The food contains this and all essential amino acids. Okay, from the diet we can get. Some of the amino acids it is prepared from our body itself. It's called non-essential amino. Okay, so synthesize our body. Okay, synthesize our body. This is called what? Non-essential amino acid. Nearly we have 25 amino acids are there. Nearly someone will be essential, someone will be non-essential. Okay, in your book it's given very clearly. Just go through. Okay. Among the 25 amino acids, only one amino acids are optically inactive. That amino acid is called what? I am going to write two amino acids. One is called, instead of R, I put H. What happened? Instead of R, I put H. So C, H, here also H, here C, O, H, here NH2. Okay. What is this? Chiral carbon or not? No chiral carbon. So this is called what? I am saying it's called glycine. The only one amino, very important one mark answer. The only one amino acid which is optically inactive is called glycine. Okay, optically inactive. Understood? The only one amino acid which is optically inactive is called what? Glycine. Then this is, I put CS3 here. So here H, CS3, here COH, here what? NH2. Understood? Right. This is called, alanine. Okay. This is what? Optically active. Are you following? Because around the carbon atom, all the groups are different, no? That's why it's called optically active. Understood? Right. So, we studied in carbohydrate, we have what linkage will be there? Glycosidic linkage. That is oxide bridge, Here on monosaccharide, here on monosaccharide, all the monosaccharides are connected by oxygen bridge. But in proteins, what bond is present is peptide bond. You know that what is peptide bond? This is one amino acid, this one amino acids are combined together. In between, what will be removed? Okay. So here, same compounds I am going to write in different way. See, outright this one outright, NH2, cut or not, NH2, CH2, COH, cut or not. Here, plus NH2, okay, NH2, tell me, CH, CH3, COO, COOH, cut off, okay. In between one H2 will be removed, no? Cut or not? So in between one H2 will be removed. So what we get? We get NH2, CH2, C double bond O, NH, CH, CH3, okay, COOH. Understood? This is called, we can say what? C double bond O, NH group is called, we can say what? Peptide bond. Cut or not? You know that. This is called peptide bond. There, glycosidic linkage. In protein, we have what? What bond? Peptide bond only linked to two amino acids. Okay, so many peptide bond will be there if you take protein. Okay. Then only we can say it's called peptide bond, but we can say dipeptide. Generally we can say dipeptide. What dipeptide means? Not meaning for 2 times CONH. This is one, 2 amino acids are together, no. This is obtained by 2 amino acids. Then only it's called what? What peptide? Dipeptide. But tripeptide, na? 3 amino acids together. Then it's called tripeptide. Understood? Okay, not meaning for 2 times CONH group. Okay, right. Note down. Finished? Right. Then here I told you already this one, listen all. Here it forms one ions, no, Switzer ion. Do you know? Have you heard about this one? It's an acid group, no? It has a tendency to produce H plus ion. So what happened? When H plus goes here, now it becomes CH, COO minus plus what? NH3 plus down R. The same species we have, positive negative charge will be there. Okay. Then it is called neutral. Then that ion is called, we can say, Switzer ion. Okay, it cannot move towards any electrode at particular pH. That's what it's called, we can say one word, we are introducing isoelectric point. We studied in matriculation syllabus, I think, isoelectric point. At particular pH, it will not move towards any electrode. But when it moves means, when it going to move, I put, no, are you following? Because of positive negative charge present, it will not move towards any electrode, but presence of acid medium, presence of basic medium, are you following? In presence of acid medium, it can move. In presence of basic medium also, it can move. Okay, if I put H plus, what happened? H plus goes here, no? H plus goes here, what happened? H plus goes here, it becomes, the product will be what? CH, COOH, correct or not? Top we have NH3 plus, down we have R. Now it consists of only one group, no? Now only one group means it moves towards what electrode? Plus, no, it moves towards cathode. Simple one. In acid medium, Switzer ion moves towards cathode. Are you following? Same as in basic medium, Switzer ion moves towards anode. Are you following? Okay, right. Okay, so it moves towards, just remember, okay, cathode, no, it moves towards what? Anode. Okay, right. I written all this. Then we have classification types of proteins. This is all study yourself. Based on molecular shape, we have what are the types? What are the types is given? Fibrous protein, globular protein. Okay, fibrous, fiber-like structure. Okay. The example also just go through myosin, keratin. Then next one is globular protein, insulin and albumin. Okay, just go through. Then another structure is very, very important. Based on structure they classify. 4 types. Primary structure means, what is primary structure? It will be linear. It will be linear. The amino acids are linear. It's called what? Primary structure of protein. Secondary structure means it consists of what? 2 types. Alpha helix and beta pleated structure. Okay. So in between the amino acids, we have the peptide bond will be there. Then only it will be, right hand screw like structure, spherical. Okay. Here C double bond O means here NH group is there. So in between C double bond O and NH group, there will be hydrogen bonding. Then only it looks like right hand screw like structure. Okay. So it will be stable because of hydrogen bonding. Okay. But it will be in a beta means it a sheet like structure, sheet. Okay, it's a screw like structure, it's called sheet like structure. Okay, Here also between intermolecular hydrogen bonding between C O C double bond O NH one side C double bond O, other side NH. So in between one hydrogen bonding is present, beta go through. Then tertiary structure is also there. Again folding of secondary structure is called, we can get fold, again fold. Further folding of secondary structure is called tertiary structure. Then quaternary structure is also there. Okay. N number of folding of amino acids, it's called what? Quaternary structure of proteins. Understood? You just go through only theoretical part. Understood? The next one, I think, denaturation of protein. Correct? Okay. D means what? Removal of nativity of protein character. Loss of biological activity of protein by heat, by change in pH. So anyway, biological activity of protein will be removed due to heat, due to change in pH. Okay, that's called loss of, simply we can say loss of biological activity. This is called, we can say, denaturation of protein. So examples I'll just go through. I think coagulation of, is there no? Curdling of milk, coagulation of egg. Then one more point is very, very important. During denaturation, underline, secondary and tertiary structure only affected, not primary structure. That one very important. Which structure can be affected, they will ask. Okay. Primary structure remain as it is, no changes. That's very important. Okay, these are all about proteins. Just go through. Okay, I think I covered all these. Right. Next one. Remaining only simple one. Remaining you can study first only the enzyme. Enzyme means what? What is enzyme? It's a biocatalyst, no? It's a biocatalyst. It can catalyze many reactions. For example, invertase. What is an enzyme? It converts sucrose into glucose and fructose. Invertase. Cymase, it converts glucose into ethyl alcohol. Like there's so many, maltase, okay, diastase, then urase, so many, it's a biocatalyst that function go through. Then vitamins also very important. Okay, the types of vitamins, water soluble vitamin, fat soluble vitamin, nothing but A, D, K. Okay, water soluble vitamin is called B and C. Okay, that chemical name. Then deficiency, sources. Okay, so just go through. Then nucleic acids, study yourself. It consists of, especially DNA, RNA is very important. Okay, DNA and RNA. What's the bases are present? That's know. DNA, RNA. What are the bases? AGCT, AGCU. That's only remember. Okay, here thymine is there. Here uracil is present. Okay, these two are combined. A and T by double bond. Correct? G and C combined by triple bond. Study. Okay. Then here also types of RNA is there. Messenger, ribosomal. One more. Messenger, transfer. No more. Transfer. Okay. Let's just go through. Okay. Then moreover, nucleotide, very important. Nucleoside means what? It consists of base and pentose sugar. Okay. Pentose sugar. The nucleotide means one more thing. Base, phosphate group will be there. Then we are studying, carbohydrate. We have what linkage is there? Glycosidic linkage. In protein we have peptide bond, no? In protein we have peptide bond. In nucleic acid we have phosphodiester linkage. Just study correctly. Phosphodiester linkage. That's very important. Okay. All the linkage study. That's all. These are all about this one, biomolecules. Okay. Okay. Structure of glucose very important. All the examples go through. Example of disaccharide, example of monosaccharide, example of polysaccharide, examples of all the some small amylopectin. We have fibrinogen. Okay, all the examples just go through. Okay, right. Next one is I am going to take. This is the first time I am going to take one more lessons in crash course. Yeah. Okay. It's a very small lesson. Then only I am taking one more lesson. Nothing but it's called polymers. Poly means what? Many parts. Mer means parts. Many parts together. No. Many parts together. Okay. Many plus parts. It's called polymers. Okay. So only we have. They classify the polymers into 4 types. Based on sources. Naturally, based on sources. Natural polymer. Okay. Natural polymers. In natural polymers is it is a protein. For following or not, we can classify into based on sources, natural polymer, then synthetic, semi-synthetic polymer, then synthetic polymer. Okay, natural polymers, we can protein, cellulose, all this we can give. Semi-synthetic means rayon, cellulose nitrate. Due to availability, we can say we can classify based on sources means due to availability naturally. Some of the polymers are obtained naturally. Some of them can be synthesized in our man-made polymer. Synthetic all will be synthetic mostly in our day-to-day life, isn't it? Nylon 66, bakelite, so many in PVC, PAN, Teflon, so many things we can say. Understood? Based on sources we can classify. Just study go through the examples enough. Next one based on I think structure. Based on structure they classify. Based on structure means we have linear branch chain polymer. Okay. Cross-link polymer. Cross-link polymer. Following? Cross-link. Linear means what? It goes on like this. Branch means we have one branch. One branch will be there. Cross-link means what? 2 linear polymers are linked by one, branch like this. Okay. Here 2 linear will be connected by one. Mostly it is present in bakelite. Best example, bakelite. Okay. Okay, understood. Right. This is all PVC, we can say. Here, the book, textbook given. This is called high density polythene. This is called low density polythene. This example is given. It's a bakelite, we can say, or urea formaldehyde, the melamine formaldehyde. This is all example. Best example is bakelite. Okay. Okay, right. This is based on structure they classify. Okay. The next one is based on mode of polymerization. This is very important. This is not a simple one. Mode of polymerization only important. I written all this? Right. Okay. Third one is, based on mode of polymerization. So here simply addition polymerization, yeah, condensation polymerization, that addition polymerization. Okay, right. Addition polymerization, we have, it is classified into 2 types. What are they? Homopolymer Homopolymer, what? Copolymer. Copolymer. This is called, copolymer. Homopolymer and copolymer. B, okay, copolymer. Understood? See, homo means what? Same, no? Same kind of, polymer means what? Monomers are combined together to get polymer, no? You know that, correct or not? Monomers. Without monomer, no polymer. So monomers are combined together, we get in presence of temperature, pressure, catalyst, yeah, we get polymers. Understood? So same monomer, homopolymer means what? Same kind of monomers. Okay, here what? Copolymer is what? Different kind of monomer. Understood? Okay, right. So here so many examples are there. I'm going to give one or two examples. See, the same kind of monomer means, best example you can take polythene. Okay, polythene. Okay, polythene. Polythene, this also they classify into two types. One is called what? Low density polythene, high density polythene. Okay. Ethene in n times, that's all. Same ethene in n times. That's same ethene in n times. Copolymer means different kind of monomer. One is one monomer is another monomer. They are all combined together in n times. Okay. Low density means in those days it is obtained through free radical mechanism. It is just note down, it's obtained through free radical mechanism. Then what is the catalyst? What is the initiator used? Means initiator is an mathematical catalyst. Okay, in those days they use what? Peroxide. Okay, but this also obtained through free radical mechanism. But nowadays we are using what? Ziegler, on scientist Ziegler Natta catalyst. Ziegler Natta is two different scientists. They got Nobel Prize by creating this catalyst. Okay, because if you use peroxide means, after prepare the polymer, this catalyst cannot be easily removed from the polymer. It will take more time. It will be very costly one. Then only Ziegler Natta, two different scientists, he set one catalyst, he prepared one catalyst. That catalyst nothing but very important, titanium tetrachloride and triethyl what? Aluminum, studied. Okay, if you use this catalyst, once polymer is obtained, this catalyst will be easily regenerated. We can easily separate. Then only it's then one more thing here high temperature we can give. High temperature, high pressure you can give, but here low temperature, low pressure you can give. So that's a main difference between low density. Is it low density? Here high density. High density means the low density means it's somewhat thin. Squeeze bottle. Insulator for tape. This is all we can able to prepare this one. Here some bottle, bucket. This is all able to prepare. So high density, somewhat thick. That kind of polymer we can able to prepare. Okay. Suppose the equations, that same kind of monomer I told you, CH2 double bond CH2 n times, no. Okay, here I told usually one put one bond polymer. First you put one bond. This bond will be extended, no, this side. So CH2 in n times goes on. Cut or not? You put n here. This is called ethene. Cut. This is called what? Polythene. You put poly in the front. Okay, understood? This is an example. Homopolymer, same monomers will be repeated in n times. Okay, so polythene only I given. So polyvinyl chloride also we can. What is PVC? PVC one. Simply replace H by Cl. Simply. So CH2 double bond CHCl. Okay. Then n times, no. Tell me. You know, I told you first one put bond, open the bracket. Okay, first you put one bond, open the bracket, then what? CH2, kata. Understood? Not CH2, here only CH will come. Kata not? Okay. N times. Kata? Right. Vinyl chloride, no, vinyl mother. Yeah, CH double bond CH, no, vinyl. So this is called vinyl chloride, isn't it? Correct or not? Vinyl chloride. Vinyl chloride. This is called what? Polyvinyl chloride. Kata? Understood? So many examples are there. You just go through. Teflon, one example. Okay. Neoprene, one example. Neoprene, one example. Okay. All pan, one example. Pan, PAN. Polyacrylonitrile, pan. Teflon, to make non-stick coating vessels. The user study thoroughly. All are what? Homomers. Same kind of monomer in N times. Okay. This is also 2-chloro, 1,3 butadiene, N times. This also pan means here CN will come. Here CN, acrylonitrile, we can say. Instead of Cl, we have CN, cyanide will come. Okay, that's the difference. All this to go through. Then come to copolymer. Copolymer. Different kind of monomers will be there, isn't it? You know that. Okay, different kind of monomer means here best example we can say Buna S rubber and Buna N rubber is the best example. Okay, Buna S means you know Bu. Bu stands for butadiene. Butadiene means what? CH2 double bond CH single bond CH double bond CH2. Okay, 1,3 1,3 butadiene. Correct or not? Buta, another Buna. S stands for what? Styrene. S stands for styrene. Styrene means CH2 double bond, CH single bond, C6H5. This is called what? Styrene. Okay, styrene. So, catalyst is what? What is the catalyst we are using? Sodium. Bu-na S. I heard about all this. Bu-na S. Bu-na S rubber. With the bristles for brushes. We are using, brush. That bristles we are using. It is used in brush. The bristles for brushes is given. So, Bu-na S rubber. Okay. Understood. Then, I would write. Can I write here? I told you before write the polymer, put one bond, open the bracket. Understood? So this will come here. This will combine these two. This will go there. Okay. Sometimes they'll give the polymer. What kind of polymer that is they'll ask. If all the groups are different means copolymer. The same group is repeated N times means what? This is they'll give. What kind of polymer they'll ask? It's called what? Polymer. Understood? Sure, right. Tell me. Put one bond, open the bracket. CH2. This one comes here, no? Single bond, CH, double bond. Understood? CH2. CH2, single bond. This bond will be extended. CH6H5. The same structure they will give. Find out this, it is a homopolymer or copolymer they will ask. Okay. So if you know this is butadiene plus different, no? So it's a copolymer. Understood? Same thing, N rubber, here styrene we can use. Not styrene, it's CN. If you put CN means nitrile. Okay, right. Butadiene, here I told you no, butadiene butadiene. Simply I am saying, not I didn't put 1 comma 3. Butadiene plus what? Acrylo nitrile. Okay, plus in presence of sodium. So bu na n rubber. Understood? Right. Same thing. Same. Everything going on here. Cn will be there. Understood? Right. Next one. That's all. Addition polymer, this and all. Then condensation polymer. A. Are you following? This is okay. Or we can write this is 1. 1 is addition polymer, and another one is condensation polymerization. Okay. Understood? Addition polymerization. Just to add the 2 monomers. That's all. Simply. Condensation means what? Condensation means when we combine the 2 monomers, in between water molecule will be eliminated. Water molecule will be eliminated. That's why it's called what? Condensation polymerization. I'll give an example. Best example is, other example we go through. Nylon 6,6 best example. Why I put 6,6 means each and every monomer we have how many carbon? 6,6 carbon. Hexamethylene diamine. Methylene. CH3 na methyl. CH2 இல்லையா வேணா சொல்லுவீங்க hexamethylene what? Diamine. CH2 4 COOH. Understood? COOH. Right? This is called adipic acid. This is called adipic acid. Okay? This also having how many carbon? How many carbon? 6 carbon. This also having how many carbon? 4 plus 2, 6 carbon. Then only it's called what? Nylon 6,6. Understood? Right. When we heat, okay, what happened? I told you, it has condensation means mostly 2 functional will be there. The compounds having 2 functional groups. See this. So here H, here what? H2 will be eliminated. Okay. Now here H is going. Here also H will be removed. Understood? Okay, right. So what? N polymer. So CH2 6 times here NH C double bond O. Correct or CH2 4. Correct or not? C double bond O. Right. This is called what? Nylon 6,6. Put right. Condensation means in between H2O will be removed. Okay, plus H2O. Whenever the 2 monomers are in between 2 monomers, H2O will be removed. That's called nylon 6,6. Other example also you just go through. So here, terline. Other one is nylon 6 only is there. Just go through. Okay. Terline, Dacron, so many names is there for this. Terline, Dacron. Here, very important. This is called polyamide. Amide group, The example for polyamide is nylon 6,6. Nylon 6 also you can say. It's called polyester. Polyester is, ester group is there. This is also polyamide we can say, polyamide. Okay. It is obtained from caprolactam. Just study, go through all this. Okay. Condensation polymer. Here in between H2 will be removed. That's why it's called condensation polymer. Okay, right. Then another one is what? That's not very simple one only. Examples you just go through. Mostly I covered. That is. Then based on, fourth one is based on intermolecular forces. Fourth classification is first and last will be, first two nothing based on sources. Second one is based on structure. Last one is based on intermolecular forces. All this, we just go through the examples. Okay. Based on, fourth one is based on intermolecular forces. Intermolecular forces they classify. Okay. You know that all these examples just go through. I think first one is elastomer, that or not? B one is fiber. Now, next one is thermoplastic. Or okay, D one is I think thermosetting plastic. Thermosetting plastic. Cut off. Here, I told based on intermolecular forces. Here, force is what? Elastomer. We can able to, it will come, no, but no force in, no force in between them. So, no force, less force will be there. Then only it will come. It will be elongated. Okay. So what? Intermolecular force is what? Less. Weak force. Correct or not? Weak force will be there. Okay. It will be come to the, it will be stretched. Okay, easily. Example, let's go through. Okay, rubber. Best one is Buenos rubber, Buenon rubber. Fiber. Is you want strong force, strong intermolecular force will be there. Okay. Thermoplastic means it is in between what? In between fiber and elastomer. In between fiber and elastomer. All the examples, all on do study one examples. Okay. Thermosetting only very strong. Okay, very strong force as well as cross-linked will be there. Cross-linked. Yeah. Okay. You following? Okay. Here best examples, bakelite is the best example. Bakelite, okay. Right. Next one is, that biodegradable polymer, no? Biodegradable polymer. Last one is, all this one example study. Two examples study. Biodegradable polymers. What is biodegradable polymer? Last one is, biodegradable polymer, no? What is it can be easily decomposed, no? It is easily decomposed. Okay. Then only the no pollutions will be there. They are saying, okay, now it is easily decomposed. The polymers can be easily decomposed by any bacterial. So that's called biodegradable polymers. Here we are using, I think on PHBB, one example is there. Polyhydroxy, butyrate and valerate. Okay, that's what it's made up of means, what are the monomers are needed means, 3-hydroxybutanoic acid and 3-hydroxypentanoic acid will be there. Is there in the textbook? Is there or not? It is given in the textbook, is there? 3-hydroxybutanoic acid, that's a, that's a monomer. 3-hydroxybutanoic acid plus 3-hydroxypentanoic acid. Pentanoic acid are together. This is a monomer to get this one. Okay. This will be easily decomposed. Then we can say it's called biodegradable polymer. Okay. It is a very important uses is it is very useful to package for any very glass materials. Orthopedic devices they put. Orthopedic means needle and all. We can use to pack. That packaging is a very good packaging material for any glass substance. Okay, that's a important uses of PHBB. Okay, another one is nylon 6,6, just right, nylon 6 and nylon 2. Nylon 2 means, glycine we can take. These are the monomer. Because nylon 2 means what? It contains only 2 carbon. Correct? It contains only 2 carbon. Nylon